Try, oh, that works. All right. So critical values separate likely from unlikely values. In chapter 7, we're only going to consider the positive critical values. But in chapter 8 and on, we actually look at the positive and the negative ones. So sometimes we may look at one, sometimes we look at both, sometimes we only look at the positive, sometimes only the negative. So it just depends on the situation. So the nice thing about these critical values is that they're symmetric because these are z-scores. So the positive and the negative has the same number value, just opposite signs. Okay, so find z alpha half, which is the critical value, for a 95% degree of confidence. Okay, to find critical values, we always draw the normal curve. 95% confidence means we're looking for, we want 95% of the times we want our confidence interval to include our values. So we're actually looking at the middle 95%. So over here we're going to say this is 95%, which is equal to 0.95. Then we're going to look at what is left in the tails. So that is our alpha. So 1 minus 0.95 gives us the area in both tails. So that's equal to our alpha. So there's 5% in both tails, which means there's how much in each tail? 2.5%, which is 0.025. Sometimes it's easier to work with a percentage, but make sure, later on when you're actually using these numbers to find area, you're going to have to convert it to decimal numbers. Okay, so alpha half is the area in each tail, which is 0.025. Now to find this critical value, that's the z-score that separates the area to the left from the area to the right. So what's our area to the left? It is 97.5. So you're going to have to actually add your center and the tail on the left. So that's 0.975. Okay, now to find z-scores, given area or given probability, we do what? Inverse norm. So all these inverse norm, normal CDF, all that stuff comes back. So you definitely have to know, when you have area given, you're going to use inverse norm. Inverse norm will give you critical values. So over here, this is our z alpha half, which has alpha half in the right tail. That's why it's called z alpha half. Okay, inverse norm of 0.975. Is equal to 1.96. And notice this is pretty close to 2, right? So our threshold from before is going to be fairly close. I mean, depending on what our percentage is. So let's do the same thing for the 90% degree of confidence. Okay, what's the area in the middle? Okay, 90% in the middle, which is 0.9. What's the area in both tails? In both areas is 0.1, and the area in each tail? 0.05, right? 5% in each tail, which gives you 10% total. So 5% or 0.05. Same thing here. Okay, now again, to find that critical value, we're looking for the positive one. Over here, looking for the area to the left, which is how much? Yeah, 95% or 0.95. So use inverse norm of 0.95. Is 1.64, and this is actually one of the ones that are rounded to 3 decimals, so it's 1.645.
Why would it be rounded to 3?
Okay, so the reason why it's rounded is because it's one of the most common ones, and it falls right in between two values. So remember when I first gave you the z-score table, there were a couple that were start. It's one of the start ones. And actually, on the last page of this handout, there is a formula sheet, and some of those, the most common ones are listed there. So for chapter 7, for all the following chapters, I'm going to give you guys a formula sheet, and you will be able to use that during the next exam as well. So just because there's, a lot of formulas from now on, it's important, for me it's important that you guys are able to do it, not so much that you can memorize everything. Okay, so let's look at the last one, another common one. And, when you do your homework assignments, they use some of the ones that are not so common, maybe like 97% or something, just so you can't just look it up on your, formula sheet. But most of the word problems we look at from now on are going to be like, a lot of them are 95. In fact, if there's no percentage given, you're going to assume it's 95, which goes with, 5% in the tails. So 99% in the middle gives you 0.99. How much in the tails? Yeah, 0.5% in each tail, because there's 1% left in both tails. And then when we convert that to a decimal, how many zeros? 2, right? Move it 2 places to the left over here, and it's 0.005. So especially with like the 99%, it's definitely easier to look at the percent first and then convert it to a decimal number. Okay, so the middle, center, and left area added together this is inverse norm of, what's the area to the left? 0.995. Okay, and that's another one that's rounded to 3 decimals.
576.
Yeah, it actually gets rounded to, what was it, 2.?
576.
Yeah, it actually gets rounded to 2.575.
The number after the 5 is
I know. It's just, again, let's look at the formula sheet. This is one that's not rounded exactly. It actually goes down to 2.575. So last page over here, we have the most common ones. And remember, these are values that are for z alpha half. And so the most common are 90% confident, which is 0.9, 95% confidence, 99%, and 98%. So those 4 are given over here. All the other ones you would be able to just find by doing this procedure over here.